Welcome back to the new video, and in this video we will start the chapter 13 binomial tree. This chapter is based on the binomial asset pricing model that is well known use in pricing of American options and also pricing of European option. This is one of the easiest method to run, and from this chapter all the chapter are more mathematically intensive, and we will run about stochastic calculation in next chapter. You can understand binomial model as a discrete time model, so it is not a continuous model, and we will start this model without any delay. So let's go back to our board, right? So here is a concept of random walk. So in continuous time means there is no discrete time strain between it. It is in continuous, right? So the random walk is also called as a drunkard man walk. So it can go anywhere, right? Like random, it is random, right? This is a random walk, right? But in discrete time, this is divided into a time stream. So a random walk will look like a tree, graph, right? From this point we will go this, from this here, this, right? This is a random walk, and this more look like a graph. And the binomial asset pricing model, we will look into deriving using this model from no arbitrage arbitrage method, and second risk neutral method. I will explain it later. What is no arbitrage and risk neutral method mean? So the binomial asset pricing model, a basic concept you can think like, right? Today's stock price is at 20, right? And let's say the probability of up movement, price going to 22 is P, right? And the down movement, the price can go up, price can go down, is go down to P 18 will be 0. Sorry, 1 minus P, right? So we have to find the option that can go, uh, we have to find the option price at T0 that can calculate the expectation of cash flow if the price is at 22 and at 18. So we will discount it. So the thing you have to remember is, right, we have to first find the path, right? Then we have to find the expectation at of future time, right? Or alter cash flow, ST, right? Let's say ST. And third, we have to then discount it at T0 minus R into T. So that's the basic methodology we follow in this. It is more involved than this. I will explain now. And now we will find the thing is, it is gone like 20. From it can go 8, sorry, 18, 22, and from this it can go 18. From 22 it can still go up like to 24, and then more 4, like 16, like this, 14, 21, like that. We can make our tree how long as time. So we discrete it, right? It is 1 tree, 2 tree. So there are model one time step model, 1 time step, 2 time step, 3, 4, 5, 3, n time step, right? So let's run binomial asset pricing or 1 time step model by no arbitrage approach, argument, yeah, approach, right? So no arbitrage, you can understand that there is no uncertainty for the value of the portfolio. The market go whenever we will get the fixed income. It doesn't matter if the market is up or market is down. We will get a equal return in every scenario. So let me explain it with the example. Let's say we have a 3 month option, expiry option with SO current price trading at $20 and with strike price of 21. It is a core option, right? Right, it is a core option, European core. And let's say after 3 months we are at T0. This is T0, right? And we are at 20, right? So it can go up to 22, right? And it can go down to 99. Sorry, 18. So let's see the equal case. If the ST is at 22, the spot price at expiry is at 22, we will earn maximum of ST minus K equals 0. That will be 21 minus $1, right? And if market go down, like so maximum of ST minus K equal to 0. So we will lose money here, right? It is below to expiry, so it will expire at 0. So option pay off, right? Option pay off. The no arbitrage market tells the no arbitrage argument tells us that these two, where when what whenever the sorry whenever no, it doesn't matter if the market go up or market down, we will get there is no uncertainty in the market. These two price, it doesn't matter where the market goes, the 22 price and this price would be equal. And if this is equal, then we can discount it using risk free rate. So we will set up a portfolio like that our payoff would be equal in both scenario. And let me tell you how. So we will use the concept of delta, Greeks, right? So we will make a portfolio of stock and short. We will buy stock and short core, and we will buy the delta amount of stock such that the both value is will be equal. So we want that if the market go up, and so our total payoff, our total profit would be 22. That is the spot amount of stock of delta amount of stock plus 1 from 1, that is core option, right? Equal to, if the market go down, we will lose, we will earn 18 rupees, 18 sorry dollar on stock, delta amount of stock. So we want this argument equal, so we will find the value of delta such that this equation holds, right? We want to hold, so it is simple linear algebra, right? It is a simple delta, here it is 4 delta, right? Delta equal to 1 by 4, delta equal to 0.25. So we will buy 25% of stocks, and in that's how we will make our portfolio risk less, right? So our position, our risk free, risk less portfolio consists of long 0.25 shares and short one core option, right? One option, right? So if stock price move 20, 22, 18, right? If it move to 22, our payoff would be 22 into 0.25 plus 1, sorry, minus 1. We shorted it, right? This is because we short it, minus 1. That is equal to 4.5, right? And if market go downs to 18, so our portfolio would be 18 into 0.25, that would be 4.52. So you can see that LHS equal to RHS. Our riskless portfolio condition holds, right? So our expectation at ST is 4.5, right? So we doesn't matter where the market goes, we will earn 4.5 in future. So we have to discount it to a present value at T0, right? So we will just discount it. That would be E minus RT. That is 4.5 dot E minus, the risk free rate is, I guess, 4%. 0.04 for 3 months, right? 3 into 12. 3 into 12. That would be 3 divided by 12. That would be 4.455. So our option price should be $4.455 by no arbitrage method, right? Sorry. We discounted it, right? So this is not the option price. This is our portfolio price, right? We remember that we have a portfolio of delta share minus core option, right? Core option, and we don't know the we want to find the price of option, right? So we will simple find we found the value of our portfolio, so we will equate it by maths. Okay, so our portfolio at T0, we had delta share, I mean 0.25, that would be minus F. So our portfolio F is a option price. So 20 into 0.25 equal minus F equal to 5 minus F, and we have the discounted value of our portfolio, that is 4.455, and the final value would be then F equal to 0.545. So that's the option price. It's so simple, right? And in reality, we can't buy 0.25 25% of share, right? So we will buy 400 option and 100 share to equity, right? So we can buy like that. And yeah, now we will go to more risk neutral approach, and we will generalize the everything, generalize this example. So let's start. SO is our current stock price, R is risk free rate, T is time of maturity, right? And up, yes, U is the amount up. I can't, how can I say? U is the upward percentage. So For upward it will be always greater than u will always be greater than 1, and d is downward movement, and it will always be negative. So the upward movement would be SOU, and downward movement would be SOD. I will show in diagram. And the future value for up, FU is a, sorry, option value if the for up part, and FD is a for down part, right? So let's start. We are SO, right? SO. The current price is at SO. We are now at SO up, right? And then we go down to SOD, right? With future price up and future price down. Sorry, option price up and option price down. So our portfolio. So like we said, we have wrong position on delta short, delta stock, and short position on option. So our portfolio would be SOU, right? SOU stock. If we are calculating if the stock price is at up, SOU delta minus FOU, right? That's how simple it is. And it is for up part, and if the portfolio value, if it go downs, would be SOD delta minus FD. That's how, right? Simple. And then because of no arbitrage condition, this should be equal, because our portfolio is riskless. It doesn't matter the part is up or part is down. So it would be equal delta minus FU equal to SO delta minus FT. From this we can find the value of delta, FU minus FD upon U minus SOU, U minus SOD, right? This is a delta, and always delta is the, you can understand the sensitivity to the underlying, or the rate of change of option or derivative with respect to its asset or underlying instrument, right? So that is a delta, and this formula has come because of this no arbitrage argument. And then, right, so we have to find the present value, right? So present value of portfolio would be like SOU delta minus FOU with respect to E minus R D, and the cost of setting this portfolio is SO plus SO minus F, SO delta minus F, right? So this should be equal because of no arbitrage argument, right? SO minus F equal to SOUA minus FU dot E minus RT. From that we can find F equal to, this will go here and this will go down there, right? SO F equal to SO delta 1 minus U E minus RT plus FU E minus RT. This is simple. We will open the bracket and we will equate the formula, and this is the value of few option if the path. So we will substitute the value of delta here, right? So F equal to SO, delta is our FU minus FD upon SOU minus SOD, and that would be 1 minus U E minus RT plus FU. Okay, that's the simple, and we after more solving we arrive to this formula FU 1 minus DE minus RT upon U minus D. This will cut down, we open the bracket, then this and this will cut down, like this cut down. After opening, this will cut down, FU na FU, like this, and how it's simple, U minus D plus FDU minus, I don't know, should I post the derivation here because my handwriting is not that good. I don't even know it is readable. I can't even understand. Okay, I will improve it. So yeah, by no arbitrage, this is the general solution, and we just put the value and we will get our output here, right? And yeah, there is a second concept, or I will tell you later how it is derived. It is easy. We discount it, and that is P is the probability of going up plus 1 minus P probability of going down FT, and discount it, find the yeah, right, that's simple. And the probability would be minus RT minus D and upon U minus D, and this formula come from risk neutral valuation, risk neutral method, right? So the probability is like that. If the price is 20, probability of going up is 0.5%, and P value is 0. And 1 minus P is also 0.5, and here the probability is calculated, right? Like if up movement is 1.1 or 1.1, right? Down movement is 0.9. So SO dot U, SO dot B, and SO dot mu. So probability would be E minus E 0.04 into 3 by 12 minus 0.9 upon 1.1 minus 0.9, that would be 0.5503. So probability would be 0.5503, right? That's simple it is. And probability of not going down is 1 minus 0.5503, 0.4 something, right? Probability of going down is 0.4497, I think, right? So that's how risk neutral valuation work. So let's explain risk neutral. So what we mean by risk neutral scenario or a market? A risk neutral market is a market where there is no extensive intensive given to a investor because he is willing to take more risk. Let me show you. In risk neutral world, if the banks, let's say bank or a FD or zero coupon bond, that is considered to be safe investment, gives 4% return, then the stock market or option market, which is more volatile, more risky, and generally in real world they have a higher return of 12% or more than 20% in some case, right? But in risk neutral one they will also have a 4%. So there is no extra intensive to keep your money in stock market or to invest your money in stock market rather than to keep in your bank safely. So it doesn't reward the person who is willing to take a risk. In that way we can simplify our maths because we can't quantify risk or emotion or risk capability of a person. Like a middle class can lose $100, $100 easily. Its risk appetite is 100, and if a investment bank is there, they can be like 100 million. So in real world, 100 million, the investment bank have a edge for this. So the pricing of the derivatives and anything related to trading become more difficult. So we for to simplify our maths, we say both stock market and banks or FD risk free rate give return at risk free rate, same return of 4%, right? So in risk neutral world, we generalize it. If the stocks start with SO, the probability of going up would be P, and probability of going down would be 1 minus P, where P will be between 0 and 1, right? Of course, it is a probability of going up, and the up movement would be more than up movement should be more than the discounting factor because then it doesn't make sense, right? That's the condition. So our portfolio worth would be value would be, if it go up, probability of going up plus 1 minus probability of going down, right? That simple it is. So we can find the expectation, right? Expectation at ST would be payoff of SOU if it go up plus 1 minus P SOD, right? And from this formula we can find the probability formula. Let's see, because expectation of ST is equal to S, right? SO dot ERT, right? So we will substitute this here. SO dot ERT would be value of portfolio, future portfolio, right? P SOU plus 1 minus P SOD. So this SO and this SO will cut that, right? That would be E dot RT equal to P plus 1 minus P D, and then it will go here. We want P, then E. So next step would be RT equal to P plus D minus PD. We will bring D there and we will common out the P. 1 minus PU. Sorry, I forgot the U. P U minus D, right? And then where is my mouse? Then would be ERT minus D. That would be P equal to U minus D. And let me check if it is right. Yes. So this is the formula of probability. So how we found it? We kept expectation, future expectation equal to expectation of SO, right? SO, sorry, expectation of SO dot ERT. And this is like probability of stock going up plus probability 1 minus P of SO going down. And that can be also written as probability expectation of FU or discounting FU plus 1 minus P D or E minus RT. And that's how the risk neutral pricing formula came, and it is very simple. And yeah, anything I left? One more revisit. Okay, so let's take this our old example with risk neutral approach. So our interest risk free rate is 0.4% or 0.4. T is our 3 months, and that is 0.25, and the SO is 20. SO is 20. So it start from 20, can go to 22 and 18. K equal to 21. So our option what would be 1. And yeah, and the probability, we will find probability 1 minus P here. And what I am forgetting, right? 1, yeah. And its portfolio value will be here 0. So our portfolio will be 22P of going up plus 18 1 minus P of going down. That would be equal to 20 discounted, right? 20 dot E 0.04 into 3 by 12, or you can use this formula also, right? The formula is P equal to ERT minus D upon U minus D, right? Up moment and the down moment. So up is 1.1, down is 0.9, E is 0.04 minus D is our 0.9. So you will get the same answer, and the probability from this would come 0.5503. Okay, and yeah, so the probability of going up is 0.5503, and probability of going is 0.4497. So our payoff from future from option would be like 0. It would be discounted, right? 0.5 probability of going up. So we will get 1 rupees plus of going down, 0.4497 into 0, and that would be equal to 0.5503, right? And then we will discount it to the present value, 0.5503 dot E minus 0.4 into 3 by 12. That is 0.545. So we got the 0.545 with risk neutral approach, and we got the same answer with, where is it? Let me show you. 545 with arbitrage method. So all both method got us the same answer. Hmm. Right, now we will see two-step binomial, two steps binomial tree. So let's say it is 20, and there is a increase of 20% at every time step. So we will divide our time into delta time, and here the delta is time divided by 2, right? So let's say it is 2 years, so delta would be 1, right? If it go to 22 and then 18, and 20% increase in this, 24.2 and 19.8, and here it is same, 18 say 19.8 and 16.2. Yeah, and we will denote A, B, C, D, E, F, G. So let's find the notation of it, right? Yeah, let's find it with simple example, then we will generalize it, right? And let's start our same example. There is a 10%, sorry, not 20%, it is 10%, about 10. So our risk-free rate, let me make it here for small, and we will try to solve it here. It is at 20 A, then we go to B, and that is on 10%, 22 and 18, and here it goes to 19.8, 16.2 and 24.2, and A, B, C, D, E, F. That's our binomial tree. And let's say we have a 6-month option. So 6 month would be like 6 divided by 12. Delta, it is delta value is 2 divided by 2. So 3, 1/4, right? It is 3 months here, 3 months here. So 3 months, and after 3 months this, right? And K is like 21, SO is 20, and so let's find the payoff. Here we will earn money of 24.2. So here we earn money 3.2 because K is 21, and it is in the money. Then this is out of money, this is out of money, this is out of money, and we will earn 1 rupees here, right? So technically, so we have to discount this first to this, then this to this. That's how the tree work. First we will find the expectation at this part, and then we will find the expectation at this part, and then we will discount it to a present value 20, right? That's how it works. And rest is out of money. So our up movement, we know up movement 1.1, down movement 0.9, R is 0.04, T is our 0.25. So probability would be same, like 0.5503, 0.5503. So our formula is like total, we are finding this for B. So forget all this, just focus on B. So we don't know this, but we know our 24.2. So 3.2 would be profit here, and here our profit would be 0. So we will find the value of this node, then we will find the value of this node, but the value is out of money, so its value will be 0. So we have to just find the value of B node, and the B node value, let's see, forget all this and see this as a one time single timestamp binometry, and we know how to value it, right? We first discount this 4 into 3 by 12, then we probability of up 0.55 0.5503 into 3.2, total payoff up moment, it is up moment 0.44907 into 0, and that is 1.7433, and we found that, right? That's the value of B node. Then we will find the value of A node. So we have now this, we don't know, and we have to find the value of B node is 1.7423, and C node is value is 0. So same equation we will apply, minus 0.04 into 3 by 12 and 0.5503 into 1.7433 plus 0.4497 into 0, and that is 0.947. So our final graph would look like with payoff 0.947 option price, then 1.7433, 0, then it will go to our 3.2, right? 3.2, then it goes to 0, and it goes to 0, and it goes to 0. That's how the binomial two times the binomial 3 works. And let's generalize this pointer notation. So we start at SO, the current price, the F is a option price. We go to SOU, one up movement, then our price would be FOU. Then we go one down movement, SOU, SOD, and our price would be FD. Then we go up again, SOU square, and our F value would be up. Then from here we can go down, SOUD, and our value will be F up down. From this it is F up down. Then in reality it would be F down up, but it will be equal. So FUD and SODD, and its value is FDD. FDD, or here d square. So this is general notation. Yeah. So our, let's say we have a delta time. We will not use t, we will use delta t, and delta value would be divided, right, 1 upon 2 t, like that. You have an idea. So we will substitute delta t instead of t from our earlier equation. That would be minus r delta t and PUFU plus 1 minus PFD FD. Yeah, that's simple. And our probability would be change to delta t minus d upon u minus d. So simple. So let's find value at each time state. So we repeat this equation. Fine. So we found FU, FD, FUU, FUD, FDD. So we have to find for FUU, FD, sorry, FUU, FUD, FUD, and we will use this term to find the expectation at this time stamp. So for us FU, we will consider this binomial tree, and that would be expectation E minus R delta T equal to PFU, go up FU, FUU plus 1 minus PFUD. Then we will find the value of FD. FD, we will look at this graph. That would be E minus R delta T PFUD plus 1 minus PFDD. And we have the value, we already know the F from our earlier equation. PF U plus 1 minus BFD, and we will substitute this value FU in this equation, and I am just writing the final output. You can do it by yourself. E minus 2 to R delta T P square FUU plus 2P 1 minus P FUU FUD plus 1 minus P square FDD. Yeah, and that's the risk neutral approach, and we solved it. So let's take a put example. Okay, now we take a put example, and that's two-step formula. Okay, for our put, we have a strike price K of 52. S is trading at 50. It is 2-year European option, and delta T. So delta equal to 1 by 2 to delta T equal to 1. And the stock movement is 20%. And for us, probability would be My risk free rate is 5%, and probability would be 0.05 into 1 minus down movement 0.8, right? So u equal to 1.2, d equal to 0.8. 1.2 minus 0.8, that would give the probability of 1 minute 0.6282. So our graph would be like this. We have first 50, then it's go 20% above, 20, 10, 60, and here it goes 50, and then we go here 72, and then we go here 32, and then 48. This is our graph, and we will find the, so for put, it is a put option, that would be maximum of k minus st and 0, right? Simple. And for k is our 51 or 52, k is 52, right. So this option here, it's worth 20 rupees. Okay, sorry, it is out of money. I thought it is core option. It is out of money. Here you can earn how much? 4 rupees, and here you can earn 52, right? 52 minus 32, 20. Here you can earn 12, but we have to discount it, so don't keep this value. And then this is out of money, and you earn, we have to find it right here. So for this, so let's find this 0, we have to find the 40, A, B, C. So C node, we will look at this graph, right? And our formula would be F E minus 20.05 into 1. We have whole formula, so we don't have to find this and find this and then add. So we finally plug and put the value, and sorry, probability of going up square into 0 plus 2 into 0.682 into 0.3718 into 4 plus 0.37182 into 20, and that gives the value of put option to be 4.1923. So the put option is obtained is 4.91923, and that's how it works. Now let's say American option. So binomial model is extensively used for pricing American. Right? Because we can find the option price at different time step, and we can what we say, compute the probability of early exercising of the option. So value of option is given by 3.13.5, right? The same formula, E minus R T P F U plus 1 minus P F D. But we have to find the payoff from early exercising. So let's take our old put option example where it start from 50, it's go to 60, then 70 to 48, then it's go to 40, and then it's go to 32, right? We found the expectation as a normal, so it is a put option, so we should not early exercising is possible, so we have to include this in our equation, right? 32. So the total payoff here it is 0. It is our strike price, I think was 52, right? Right. Here it is 4 and here it is 20, right? And for here we used it was 0 and our pricing came to 14147, right? I got that. But if we early exercise here, right? Here we will get the loss of minus $8, but we will get the profit of here it is 40, right? And this is 50. 40 of $12. So we will discount, we will multiply the probability of going down with 12, right? Not with anything else. So with 12, right? So we will use our old equation 0.5 into 1. Probability of going up would not change. So probability will not change, spot price would not change, only the what we say payoff would change because of our early exercising. Into 1.4147 plus 0.3718 into 12. So here is the difference, and then 12, and that gives us value of 5.0894. So American price is 5.0814 and European price was 4.1923. So you can see there is a difference. So American option is always little bit expensive than European because of incorporation of early exercising, right? So let's go to delta. So we seen that delta is sensitivity with underlying, sensitivity of instrument with underlying. So you can also price of hedging, it is also called used for price of hedging, to find the price of hedging. And yeah, for us delta can be calculated like one, our formula fu minus fd upon u minus d. This formula is perfect for calculating the delta, but you can calculate at every timestamp. I mean, like here it is our binomial tree that start from 20, goes to 22 and comes to 18. So we have to find the value of delta from changing 1 to 0, this value delta, right? Delta here. So you can price of fu minus fd in price of up minus down, that will give 0.25 of delta, and that's how you can find. So every timestamp you can use this formula to find the delta. And let's another important, we have to match the volatility. So 13.7 shows the matching of volatility. So up and down movement should be according to the market volatility, right? and volatility is what we say, rate of change of randomness or price change, or you understand what is volatility, right? Delta T and U and D and P, we all know what the P is probability up and down, and delta T. So our probability formula was right. So we want delta value such that, so volatility is defined as a standard deviation in return in short period of time, right? Or delta T, sigma delta T. That's how it is done. And you can, there is a whole derivation, I guess. Yeah, there is a whole derivation. So let me show you. So the derivation say that the price movement of going up, right, with probability P is 0.1, and price of going down with probability this is D minus 1, right? So we will it follow the volatility match, that will be both probability of U minus 1 square plus 1 minus P D minus 1 square. It is expectation formula, variance formula. We know the variance formula, x square upon minus P upon expectation x square, right? This is the variance formula, and we know that expectation equal to probability of both. Let me show you in proper. So volatility is standard deviation of variance, right? And variance formula is expectation of x square minus expectation of x whole square. So we know how to find the expectation using binomial model, right? First we will find the expectation of x square, right? So expectation minus 1 plus probability of going down, right, square, and then we will in whole bracket we will keep like that. It is simple. Ah, plus 1 minus P D minus 1, and that is whole square, and if you solve it you will get delta T. Many item will cut, and from that right we can also substitute value of P, value of P into equation, right? And that will also give us the delta T. And if we make a square root of variance, so our up movement would be expectation of, right, and our down movement would be negative of sigma, and that's how we match the volatility of market. Plug the sigma value and you are good to go. Okay, and that's how simple it is. Reason theorem is important. So let's derive the general final binomial tree formula, right? Our u is in delta t, or d is exponent of negative delta t, and probability equal to a minus d and u minus d, and a equal to er t, right? That's the formula, and you just plug the alter value and find the discounted cash flow for every part to till 0, and you will find the option price. And yeah, increasing the number steps. So for European option, if the number step, right, there are 1 2 binometry 400 500, we can go for a large number so that it would incorporate very closely and consider every scenario, right? So for now we are considering very broad scenario of between 20 to 8. We can consider between 22 to 21, 20 to 20 19, or 0.5 difference, like that. So we have to build a large number, and the computation will be what we say expensive. But uh, there is, as we increase the steps, it come close to Brax-Coles formula. And there is a derivation at the back, you can read that formula. So if we increase that, it converges to Brax-Coles formula, and you can understand it, right? So let's say option on other asset. So binomial tree for other asset. First, right, dividend paying stock. So for dividend paying, you will just keep everything same. Only a value would be changed, and q is the dividend rate. So our total risk free rate would be subtracted by dividend, so our return would be same. So er minus q delta t delta t sorry, er minus q will change, but everything would be same. So probability would be a minus d upon u minus d, where a equal to er minus q. Okay, and you use Devigram software to price it. There is a, or let me, at the end of, if my Excel work at the end, I will show you how to use Devigram. And yeah, and for option on currency, only a value would change, e from our reserve, it is our currency minus foreign currency delta t, right? For currency option, this will change. For future option, probability would be 1. Probability, because there is no initial, what we say, cash or premium required to enter, so it would be like this. And the formula would be FOU for futures, 1 minus the FOD equal to FO, right? Yeah, that's how. And for, yeah, that's it. I i don't know, it is not complete. I was just tried to code the binomial 1 time step model. Now I will code the binomial 2 time step and multi time step binomial model for American put and call everything. So let me show you one time state model. I have a code ready for that, right? For so it is option time. I imported all the library needed. Then option time core value is 1.1 and put is, so we have to check the condition because it is not negative, and or there is a condition u should be greater than 1, and yeah, it should be 1.0, right? 1.0. And then I store it in an array, and then I return it. And some here I found the probability using the formula. And this is the one time tree option pricing model, where if it is a core option, the uh, payoff of up would be core option payoff, and down would be core option payoff. And S is an array of 22 or 18, the both possible outcome, and 0 1. And then option price, I discount the total payoff of portfolio. And for put option, I just switch it to the put formula. And here I recheck the condition, and I, what we say, percentage. So I created a node, every node here, and then it is a error showing message. CP is option type, and this is the main code. K is a strike price, SO is our spot price, and it is put option 1.1 and 0.9 change. And then I found the node from here, and the T is a time frame and risk period. And I found the probability, store it into P, and passed into our binomial model. And then the plotting is not correct, just see the option price. You can see the option price here. I didn't join the plotting, I am working on the plotting, and that's the option price. And let me open the Devigram. Spotify, sorry, file, documents, and folders, Quant, option future, and other derivative. No, sorry, it is on downloads, I guess. Where it is? Devigram. I don't know where it is. Excel. Sorry, I deleted it, so I don't have it right now. So yeah, that's all for this video. It was little bit longer video, and it took time to make it. I hope you like it, and make sure you install the Devigram software. I will install it now and solve the back question, and it is really nice and easy. Or if possible, try to code it and put the value in it instead of software, so you will understand how to code it into Python. And thank you for watching this video, and I will see you in the next video. Bye bye.